Hello, my name is Cornelia Stramm. I'm working at Fraunhofer Institute Process Engineering and Packaging in Germany in the location Freising. Today we visited Everchemtech in Korea, and we are happy to hold now the online seminar for Everchemtech. I will start the presentation with the title How to Make Packaging Sustainable. Here's the outline for the presentation. I will start with a short introduction about Fraunhofer and about the Institute Fraunhofer IVV. And then I will tell you some words regarding sustainability of packaging systems. And then we divided the presentation in 3 parts. And I will start with bio-based materials, and 2 colleagues will go on then with the topics paper-based packaging applications and circular barriers. So Fraunhofer Gesellschaft or Fraunhofer Society is a big research organization for applied research in Germany. And we have 76 institutes working on different topics in the research area. You can see here on the map the 76 locations of the different institutes spread over Germany, and below or in the south of the map you can find Freising, the location where I'm working. For the financing model of the Fraunhofer Society, we have the rules that we have to earn our money by 2/3 with public funded and industrial projects, and 1/3 of our budget we will receive from the government to make some pre-research work like patent applications or so on. Besides the institute in Germany, we are also active over the worldwide, and therefore we have foreign affiliations and also some representative offices. And you can see here also on the map that we have such kind of office in Seoul also. Let's come to the Fraunhofer IVV. IVV is the shortcut for the German wording of process engineering and packaging. Our institute have 2 locations, one in Freising and one in Dresden. We have around 330 employees working on these both locations in different departments. But we have also good cooperations with the university, and you can see here a high number of different universities in Germany where we cooperate in projects. And besides this information is that university carried out the basic research work, and Fraunhofer work in projects directly with the industry to find applications and to bring the products to the market. This is a big difference to the work of the universities. On this slide you can see the 9 scientific departments working at Fraunhofer IVV, and we clustered these research departments also in business field to address better the market that our customer can find our activities. Process engineering is based on the development of food processes, and therefore the 2 main business fields are food and packaging. Besides this, we have the business field processing machinery, product performance, and recycling and environment. I will give some examples later in which focus these areas are working. Our institute leader, Professor Andrea Büttner, has also a chair at the University in Erlangen for aroma and smell research. And we have also the institute leader, Professor Jens-Peter Maischak. He is located in Dresden, and he is also a chair at Technical University in Dresden for processing machinery and process technology. So then I will tell you some words regarding the different business fields. The business field food, they develop food with good quality, and they try to replace in many projects meat-based recipes by plant-based recipes to produce healthy food types. And also the optimization and the insurance of the quality of food is a big topic. In the business field product performance, the colleagues look for the sensory evaluation of different products to check off orders and to avoid such things in consumer products. In the business field processing machinery, we are strong connected to the packaging part, and the colleagues looking for thermoforming and sealing process, but also for cleaning the processing machineries by the filling process. Then we come to the business field recycling and environment. Here we develop on the one side a solvent-based recycling technology to recover polymer materials from automobile, construction and packaging applications. And on the other side, we use plant-based materials for technical applications, for example, for lubricants, to bring here bio-based additives into these technologies. Regarding the business field packaging, I have two more slides to go a little bit deeper here in this field. So we look for the right functional packaging material for different applications and try to reach the best barrier properties to protect the foodstuff. And therefore we have also the permeation analysis in the house and can characterize the materials and processes. And beside this, also very important, the machinability of these materials, to use the best materials to have a fast processing. And also the compliance for food packaging is very important, so we evaluate also here the materials and cooperate with the industry. We will come to the department materials develop, where I am working. We have here 3 thematic groups in this department. Functional materials. Here we carried out projects based on fossil polymers and try to functionalize these materials for packaging and encapsulation applications. Then we have the group bio-based material. Here we work with biopolymers and renewable materials, and also in combination with paper to establish good packaging concept. A small group is the shelf life modeling. Here we try to predict, based on mathematical models, the shelf life of the packed food and to optimize the packaging systems to reach the best shelf life. How we work in the projects. We have a pilot plant area where we have extrusion and coating lines to process the materials and to create some demonstrators. And in the labs we can analyze then the different properties like mechanical, optical and barrier properties. So the big question is often how can I make my packaging material sustainable? And if we look for a packed product, the important thing is the protection of the filled good. And the protection is often transferred into the barrier properties. You have to protect your product, especially food, against oxygen and water vapor transmission, so that you not lost the quality of the food products. But also aroma and conformity is really important to have the right protection. And if you want then to bring sustainable materials in the structures, you have to decide which way you want to go. If you want to work with fossil-based materials, you have to develop recyclable structures, and then also you have to integrate recyclates to reach this goal. And on the other side, you can work with bio-based materials. Then you have to look for the biodegradability of these materials to match here the points. So especially for food packaging, you have to aware that most energy is binded in the food and not in the packaging material. Therefore, you have to avoid food losses by spoilage, and therefore you have really to take care if you optimize or change something in the packaging structure, that you not lose your barrier properties and reach to full food spoilage in this area. We translate this often in such diagrams. You can see here the water vapor transmission rate on one axis, and on the other axis the oxygen transmission rate. And then we displayed in such areas the requirements for different food stuff, how we can protect for a defined shelf life these different food stuff. For example, the orange area is for dairy products, and so you have to match with your packaging material this area to ensure the shelf life of dairy products. And you can use such diagrams for all different applications. On the other side, if you come from the material structures you have developed, you see here different combination of common polymers used for packaging applications. We measured here also the barrier properties against water vapor and oxygen, and printed in where you can find then the results of these structures. And in the case you want to replace these different materials by a monomaterial, you have to take care for the barrier properties, because these materials are very good optimized. And for example, in structure based on PET, EVOH and PE, you can reach very good barrier properties against oxygen and water vapor by 70 micrometer thickness. And if you replace this by monomaterial PET, you need more than 1,000 micrometers, and this is not sustainable. And therefore you have to find smart solution when you replace packaging material. Let's go on with the biopolymers. I will explain a little bit how we are working in this area. So often we use byproducts from renewable resources that we try to bring them in new applications, and therefore we have to look for good functionalities that they can fulfill all the requirements which are necessary for food packaging applications. And you can divide it, the polymers, in 4 different sectors. The one fossil-based is clear, I think. Then we have the one sector, the polymers are bio-based and biodegradable. But we have also in different materials that are bio-based but not biodegradable, or that are fossil-based and they are biodegradable. And so you have to look what kind of mission you want to follow, which kind of material you select for your packaging applications. In this diagram you see the most used polymers for packaging application, which are bio-based. And you can see that the share of the so-called drop-in solutions are relatively high, and the really bio-based polymers, the biggest part is by PLA covered, and you have to look which kind of functionalities you can use for your different applications. If you want to go for biodegradability, also the biopolymers differs, and you have to check which end-of-life scenario you want to follow. If you have industrial compostability units, if you want to use the materials on home compost, or even marine biodegradable. And therefore you have to select the right material with these properties can fulfill. On this slide you see different applications used with biopolymers, and often you can find here fresh products with short shelf life, because the barrier properties are often not so high of the biopolymers, and especially the water vapor barrier is not so high for the biopolymers because they are polar materials, and therefore often products with short shelf life are used for this. I have here then now two project examples. The first project example, we developed coatings based on PLA and PHA, where we try to coat paper to improve the barrier properties of the paper and not disturb the recyclability of the paper stream. And the second example is an extrusion example with a thermoplastic biopolymer. It's PLA. As the PLA barrier properties are not sufficient for very sensitive food product, we try to improve the barrier properties by a protein and by a wax layer, and in between two layers of PLA to improve the barrier properties for MAP products, which are the sensitive food products. And we were successful to integrate this layer and compare this tray concept with the conventional polymer materials, and we received the same shelf life of the PLA-based material. And we checked also the recyclability of this material, and it was possible to receive a good quality of PLA again after the recycling process by mechanical and solvent-based recycling process, so that we can use again the PLA for film forming. So hopefully it was possible to give you a short introduction to the bio-based materials we are working on. And in the next part of the presentation, I will skip to my colleague Stefan, and he will go on with paper-based packaging.